So we have this game here called Tower of Hanoi, and all it is trying to get these disks from the starting post to the ending one. The only rule that we have is we're not allowed to stack larger disks on top of smaller ones. So we can make this any size we want. We can start off with as many disks as we want, but the more disks we have, the harder it becomes. So the goal of this video is to give you some insight into how to do this program. So this is the complete program. I'm not going to show you what it is, but this one's just starting out with 5, and it's going to take you step by step of how to solve out this problem. So eventually we'll get to all of the disks on the last post. So the beginning of this problem is a little daunting to try and figure out, but let me give you a hand in at least the beginning, the starting of this. So let's just start off with the function declaration. Let's just call this Tower of Hanoi. I'm going to give you some parameters. So let's give you a int n. This is going to be the number of disks. Let's give you another int, which is going to be from int 2, and then int, let's call it aux for auxiliary. And all these mean are going to be the posts that we're talking about. So the from post, the to post, and the post that we're not going to be using, the auxiliary post. So let's make this a little more visual. Let's say I had our towers A, B, and C. And let's make some really small, simple cases, and then we'll see if we can try to extract some patterns from it. So let's just say I had Tower of Hanoi, and I was to give it a 1, so it's only going to be 1 disk. From, let's just say we're starting at A, so we're starting from A, trying to get to C, and the one that we're not going to be using is B. So I mean, this is pretty simple. All we're going to be doing is just going to be saying moving A to C. So let's just write that down. Move disk from A to C. Alright, easy. So now let's just try something a little harder. So now, let's just say Tower of Hanoi, and let's give it 2 disks now. And we still want to try to move it from A to C, and B is going to be our auxiliary. So just give this another one. So from here, what could we do? We could say, well, first off, we already have this function, right? We're able to just move 1 disk at a time. How will we try using this? So for Tower of Hanoi, let's just say, change colors, just so we don't get confused with the other one. Let's say we just want to try to get this one out of the way. So move top one to B. So let's just write that down. Tower of Hanoi. Let's say move 1 from A to B, and then C, which is going to be our auxiliary. So once we move this one, let me actually write this out just so. So this one is going to be moved here. And then we just want to move the one on the bottom to C. And then we'll use another recursive call to move it from B to A. So if that doesn't make sense, maybe this will. So right now, this disk is on B. And I can just say move disk from A, so we're talking about this one now, from A to C, and then we're just going to call this function again, moving 1, so TOH, to move this disk, which is currently on B, to C. So 1 from B to C using A as auxiliary. And this is kind of a roundabout way, but you're starting to see that we're starting to use recursive definitions. So let's just take this one step further. Let's move this over. Let's say we had a third disk and we try to write out this definition now. So let's try it. Let's make this green. So Tower of Hanoi, let's say 3, and we're trying to move it from A to C, A to C using B as auxiliary. Now what would this be? So we already have the ability to move 2 disks at a time to any post that we want. So let's just use that function again. We're able to say TOH of 2. We're going to try to move it from, we're going to try and get rid of these 2 disks. Just get them out of the way, put them on B. So then we can move our last disk to C. So let's just write that out. Let's try to get these 2 disks out of the way. So 2 disks from A to B using C as auxiliary. And then we're just going to move A to C. So move disk A, move disk A to C. And then we're going to want to use our function to move 2 disks at a time again to C. They're currently here, we're just going to move them to C. So TOH, move 2 disks from B to C, A. So I think you're starting to get the picture. All this is just going to be recursive calls using previous definitions that we had before to our new ones. So let's try to generalize this. We already have from, to, and aux. So looking between our higher number of recursive calls, anything higher than 1, we start to see that, pick some good colors. So A is going to appear here and here. C is always going to appear here and here. Then B is always going to appear here and there. And it's going to be the same thing. It's going to be the same thing on all higher recursive calls. So B A, and what did I use last? Gray. C. So this is a really good lesson because we learned that recursion is a lot of the time is going to be revolving around taking larger problems, then breaking them into smaller and smaller problems until we're able to get a good idea of how to really do this. So knowing all of this, it's going to be your job to create a working function for Tower of Hanoi. But there's still something we need to cover, which is this right here, the move disk from A to C. So this is our algorithm. We haven't talked about our data structure yet. What we're actually going to be acting on. So let's talk about that now. You might have some ideas, but there's something new that we want to introduce called a vector. So this is just the C++ reference. I'll leave a link in the description below. But vectors are essentially just arrays. So where is it? Yeah, so vectors are essentially just arrays. They're accessed the same way, just using bracket notation, but we get some nice new functions that we can work with. So I'll let you look at this by yourself, but there's some ones that I want to point out. For example, pushback, popback, and I think that's it for what I want to show you. So pushback is just add an element to the end. So if I wanted to, so right now we're starting off with an empty vector, but I can push these numbers on here and then just print them right out. So if I run this, I'm just pushing these numbers and I can print them out using bracket notation. Also, this one right here, size. You don't have to know what the size of this is beforehand. You can just use this function and you'll know exactly how many times to iterate through this. So this right here is just pushing more numbers on, using that same thing again. And then we can do something like x dot pop back. Let's do this like that many times. And if I were to run this again, we're going to lose that many elements. Oh, what happened? Oh, it probably pops too many times. Yeah, so now I only have just 7. So even though this is a vector now, this isn't anything really that fancy. In fact, we can still use old data types with these new ones. So for example, I can say something like vector int, so this is just my data type right now, and let's say y bracket, and let's give it something like 4. So now this is going to be a array of vectors, and if I wanted to try and access this, so let's just say y3 dot push. So let's back up. y3 is going to access the third vector in my array, and then I can just do whatever vector operation that I want on it. So I can do something like dot push 3, and essentially we have a 2D array of variable size vectors for one of their dimensions. So I hope this is going to be, well, I hope you see the use in using things like this for the Tower of Hanoi project.